Okay, we'll answer these two questions in reverse order, looking at part A, B, and C before we answer the one at the top. Let's look at this one. So it's 53 here, it is x here, you're trying to find the angle of x. Now that is the arc both these angles are standing on. So angles subtended by the same arc are equal, so x must be equals to 53 degrees. Easy. This, you got to be a bit careful. Now this, in a way, is related to a tangent. So if I have a center, I have a line, and that is a tangent. So the radius and tangent always meet at 90 degrees. So you know that this particular angle here must be 90 degrees. Next, you know that this is the radius of a circle. That's also the radius of a circle. Therefore, this triangle here must be isosceles. So if that's 21, that must be 21. Now, if this is 90, so this whole thing is 90. So y must be equals to 90 degrees, take away 21. Why? Because this is the radius and tangent, and radius and tangent always meet at 90 degrees. That gives you 69 degrees. So angle y is 69. Thus, how do we start? Well, that's 57. That is the angle at the circumference, angle on the circumference, and then angle at the center is twice circumference, so that is 57 times 2, which is equals to 114 degrees. So the next thing, have a little thing. What do you think? Can you see this triangle here? That is an isosceles triangle. Why did I say that? Well, because that is the radius, that is the radius. So therefore, two lengths are equal, it must be isosceles. And if I want to find the angle of x, which is here, x in this case is 180. Take away 114, the whole thing divided by 2. Without using the calculator, I can work out that this is 66 divided by 2, and that's equals to 33 degrees. Now look at the question at the top. A, B, C, D are points on the circumference. So I have A there, I have B there, I have C there, I have D there. The line EF is a tangent, so that's okay. Line EF is a tangent. Now we notice there's no radius there, therefore we don't need to use the 90 degrees property. Next, you're told that angle ADE is 63, so that is 63. Find the angle of ABD. Let's look at ABD carefully. That's ABD here. ACD. ACD is here. Looks complicated, but it is actually quite an easy question. If you look at this, remember alternate segment theorem. So if I have a circle, if I have a tangent, if I have a triangle that goes like that, alternate segment theorem tells us that this particular angle here must be the same as this angle here. Comparing these two diagrams, this is 63, therefore this is also 63. So we know that ABD is 63. Now ACD is actually the same thing. Now, if I were to draw this again, looking at this, see, this can also be found by using alternate segment theorem, because that angle there is the same as that angle there. So I can say that angle ACD is also 63.